based on that. So before we do that, let us quickly write. So I will not derivation part we have done so many times, right? So let us write what do we know about the projectile motion. Okay, so yeah, there are two kinds of projection. So one would be the angular projection, right? One would be angular and the other would be horizontal projection, right? Let us take the angular one. So in angular one, the body or the object is projected with some angle, right? Let's say theta. So this will go like this, right? And then this is, so this projection is u vector. So this is the initial velocity. And this will have a horizontal one and the vertical component. So ux would be u cos theta and uy would be u sin theta, right? And this projectile will go like this, right? And then it will come like right. So you guys tell me that what velocity is always fixed in the projectile motion? What velocity is always fixed?
U cos theta.
U cos theta, right? So the horizontal one, ux is constant. That is why we have ax acceleration in the x direction, that is 0, right? And at this point, this is called the maximum height, and this is represented by h. And then this horizontal distance, total distance covered, right, in x direction, that is called range. And the time in the air is called time of flight, right? So time is time of flight. Okay. So these parts, and we have derived that time of flight is how much, guys? Do you remember? What is the
U
time?
sin theta by
2u.
G. 2
2u
U sin
sin.
theta by G.
Yes, 2u sin theta by g. What is the height, maximum height?
U square sin square theta by
Yes,
2G.
by 2g. Good. And then what is the range?
U square by G uh, sin 2 theta.
Yeah, u square sine 2 theta by g. Good. So this is 2 theta. Good. So these are the values that we should remember, right? And all the question would be based on that. Remember that we are dealing with the vector quantities, right? So whenever we talk about the components, then there would be x and y component, but the ultimate thing would be the vectors, right? Okay, so keeping that in mind, now let us do some questions. So only this part is very important, that ux velocity would always be same, right? This part we need to remember. And at this point, the vertical component of velocity is 0, right? So there is only a velocity in this direction. Keeping that in mind, now let us do some questions, right? So this part you already know, so no need to note it down. Okay, yeah. So which out of these does not affect the maximum height of a projectile, right? So first let us write what is the maximum height of a projectile. Maximum height of a projectile is u square sine square theta by 2g, right? So it is dependent upon initial velocity, it is dependent upon the angular of projection, it is dependent upon the acceleration due to gravity. So angle of projection is there, acceleration due to gravity is there, magnitude of initial velocity is there, right? So what would be the correct option?
Mass of projectile.
Mass of projectile, right? Good. Now, in a projectile motion, the velocity is perpendicular to acceleration at no instance, one instant, two instants, all instants. What would be the option? Yes. So you guys draw the diagram, right? And tell me that at what instant, right? At what instant, how many instances the velocity is perpendicular to acceleration. Remember, what is the direction of the acceleration?
X.
X,
X-axis. Like it
X
goes from
axis.
up.
North is X axis. East, east is X axis, right? So you have this north, south, east, and west, right? So where is the acceleration?
East.
East.
East. Okay. Just now, you guys, we discussed that there is no acceleration in X axis. But whenever we get any confusion, we draw the diagram, right? So what is the diagram? The diagram is this, right?
Yes,
And
sir.
Yes, sir.
where is the acceleration? This is the acceleration towards the surface, right?
Yes, sir.
Because there is only acceleration due to gravity. Gravity is always towards the surface, right?
Yes, sir.
Okay, now you guys tell me at how many instances. So at this point, the velocity is in this direction and acceleration is in this direction. So is it 90?
No.
No, right?
No, sir.
And
180, right?
yeah, so not 180, but less than 180, right? And at this point, this is velocity, and at this point, this is the velocity. At what, at how many instances the velocity is perpendicular? At this point, this is the velocity, right? And this is
Sir,
our,
there is no instant like that.
there's no instant. Okay, so Akib is saying 0. What about Rishida and Siddhika? What about you guys?
Oh, no instant, sir.
No instant. Okay, for you also. Siddhika, what about you? So if I draw the instant, okay. Siddhika, first you tell me the answer. How many points? What did you understand the question? We are making the angles between the velocity vector and the acceleration vector. And we are finding that, okay, so Siddhika has said 0. All of you said 0. Now, what is the direction of the velocity vector at this point? At the maximum height? Is this the velocity vector at the maximum height? Yes, guys. At maximum height, there is only horizontal. There is only
Sorry, sir.
So at maximum height, there is only horizontal velocity, right?
Yes, sir.
Yes, sir.
And this is the gravity. So what is the angle?
1.
1. So there would
9.
be Yeah, so there would be one instant. Understood, everyone?
Yes, sir.
Okay, so these were the conceptual questions, right? And now, so this diagram is very important, right? This diagram is very important. Whenever we are confused, we make this diagram. Okay, now this is again about this diagram. This is a peculiar diagram. So a particle is projected with velocity u at an angle of, so the particle is projected with u velocity at angle of theta with the horizontal at t equal to 0, right? So time starts from here. What is the magnitude of change in the velocity, right? What is the magnitude of change in the velocity of the particle when it is at maximum height? Okay, so I will give one hint to you guys that what is the initial velocity vector? What is that? Can you guys tell me?
Sir, please can you explain again? I didn't understood.
Yeah, so the question is that the particle of projected with u velocity. This is the magnitude, right?
Yes, sir.
So I am asking that what is the velocity in the vector form, right? Remember, we are doing the motion in two dimensions, right? So
Yes, sir.
whatever vector we write, it will have how many components?
2.
Component, right? So this would be uxi plus uyj, correct or incorrect?
Yes, sir.
So
Yes, sir.
now you guys tell me what is ux?
U cos theta.
U cos theta, absolutely right. U cos theta, and what is uy?
U sin theta.
Sin theta. So this is our initial vector, initial velocity, right? This is the initial velocity. Now,
Yes, sir.
what is the magnitude of change in the velocity? So first we have to find the velocity, right, at its maximum height. So at this height, right, what is the velocity which is there and what is the velocity which has become zero? Yes. So at
U cos theta will be
yes,
u cos theta, but u sin theta will be 0.
absolutely right. So this is the final velocity, right? As Rishita said. So you have this velocity, you have this velocity. So now we have to
Sir,
find. Yes, yes, sir.
how U sin theta became 0?
Okay. So at this point, you had two components, cos
Yes, sir.
theta 1 and sin theta 1, right?
Yes, sir.
But at this point, this has only the horizontal speed, right? And
Yes, sir.
we know that throughout the journey, what speed is same? So ux would be ux, right? So in horizontal direction, this velocity will always be the same. But
Yes, sir.
at this point, we don't have any y component. So if
Yes,
we
sir.
don't have any y component, which means that vy is 0, right? And
Yes, sir.
vx is ux, which is u cos theta, as Rishita said, right?
Okay, sir.
So this is the velocity at maximum point. Okay. Now, yeah. So now we have to find out change in velocity. Change in velocity is v minus u, right? So this is u cos theta I minus of u cos theta I minus of u sin theta plus of j. Right, so this is u cos theta I minus u cos theta I minus of sin theta j. Okay, u sin theta j. So this I component cancels and change is minus u sin theta j. So what is the magnitude? They are asking us to calculate the magnitude. So magnitude would be just mod of that. So magnitude would be u sin theta. Okay, and minus j is the direction. So any doubt in this question?
No, sir.
Okay, everyone, please note it down and then we'll do the next question. So whenever you guys have noted it down, please tell. And if you have any doubts, so please ask. So how did we calculate the magnitude? This was the vector, right? So
Yes, sir.
magnitude is, let's say I write as delta u mod. So mod is root of x square component plus y square component, right? This is how we calculate. So this would be u sin theta whole square plus 0 square. So this would be u sin theta. That is how we have calculated this magnitude, right?
Yes, sir. Finished, sir.
Finished. Rishita and Akib, what about you guys?
I'm done,
Yes,
sir.
sir.
Okay, so now let us, now let us do the next question. So we will quickly finish this topic today, and in the next class we will do the relative motion in 2D. So in today's class, I want to finish this topic. Okay, so the sixth question, a particle is projected with a velocity of u, making an angle theta with the horizontal. So again, this diagram. So first few question would be based on this diagram only, right? So we have this projection and this magnitude is u, this is theta, right? Now, at any instant, its velocity becomes v, which is perpendicular to the initial velocity u. Then v is what? So we have to figure out at what velocity this velocity has become perpendicular to this u velocity. And so at this point it is this. At this point it is this. At this point it is this. Right? At this point it is this. So is it perpendicular to this one?
No, sir.
No, sir.
Perpendicular to this one?
No.
Perpendicular to this one,
No.
right? Because this, remember, I can always take this vector in here. So this is this direction. Now then I have to go down, right? And this is my, so now is this perpendicular?
Yes.
Okay, so this is V, right? This is my, let's say,
You.
U, right? And this is the angle. Okay, so this is, let's say, some angle theta. And we have to find out what would be this V velocity. So let us draw this triangle in here. Okay, this is theta, this is my V, and this is my U. So how are these two related? Which trigonometric ratio relates
Pi u tan theta. Sorry, u by v is tan theta.
U by V is tan theta, right? So tan theta is U by V. So V would be U by tan theta. Oh, this is, so this is U cot theta. Okay, let me draw this a proper diagram. So this is this is this, and then this is this. This is theta, this is U, and right, this is my V. Okay. So then in here, this, in this case, oh, okay, so this should be U tan theta, right? But I'm getting a cot theta. You guys see that at an instant its velocity becomes V, which is perpendicular to the initial velocity. So I have this U vector, right? And then this V vector. This is the V vector, right? And then this is my angle theta. This is the proper diagram, right, guys?
Yes, sir.
So then this is theta, so this is U, this is V. So then tan theta would be perpendicular by this space. So V would be U tan theta. So this is the correct diagram. And this is the correct diagram. So not this one. Okay. So did you guys understand this part? That let me make a proper diagram. Right. So your U vector is this, right? And
Yes,
now
sir.
your V vector is this. Okay. So this is your V vector, this is your U vector, and this is 90. And this is angle. Okay. So this was the angle, right? So this is theta, this is V, and this is U. So this is the proper diagram. This is V, this is theta, this is U. So then your tan theta would be perpendicular by base. So V is U tan. Okay, this is how you make this diagram. Understood, everyone?
Yes, sir. Yes, sir.
Okay, so please note it down. Please note it down. And if you guys have any confusion, please ask.
Finish, sir.
Okay, what about Rishita and Sitika? What about you guys?
Done, sir.
Oh, 1 second. Oh, sorry. So, yeah. Yes, yes, please note it down. Sorry, I did that one. Yeah, so please note it down, Sitika, and then we'll do the rest of it. In this way, it is making a 90-degree angle, right? Noted, Sitika. Good. So now, let us do the next question. So the range of projectile with horizontal, the range when the launch is running cut to the horizontal is this kind of question. Okay, so we'll do that. We'll do two questions and then we will move on to the. So let us do this seventh question. So the range of the projectile, right? Range of the projectile. This is launch at 15 degree. Oh, so this is a greater degree, but let's assume that this is 15 degree. With horizontal is 1.5 kilometer, right? So what do we know? We know that range,
X.
yeah, range is u square sine 2 theta by g, right? This we know.
Yes, sir.
And it is given that this is 1.5, right? And this is u square, and this is sine of 2 theta. So sine of theta is given 15 degree. So sine of 2 into 15, and
30.
yes, so sine 30. So we know that this is 1.5. This is u square. We don't know u. We don't know g. We know, right? So sine 30 divided by g. So let us calculate this u square by g. U square by g would be 1.5 divided by sine 30, right? So this is 1.5 and
Sir,
one, yes,
wouldn't it be easy to use sine 30 value?
yes, yes. So we will use that value, right? So sine
Okay, sir.
30, sine 30 is 1 by 2, right? 1 by 2, so this will go in here. So u square by g is 3, right? This value we have calculated. Now you will see that what is the use of this value. Because to calculate u square, to calculate range, we need this u square by g value, right? Okay. So the range of projectile when launched at an angle of 45 degree to the horizontal. Now the theta has become, now the theta has become 45 degree, right? So range would be u square, let's say this is new range, and initial velocity and g is same, right? So this only the angle is changing. So u square by g and sine of 2 into 45. So this is u square by g sine of 90. Sine 90 is 1, so this would be u square by g. And we have calculated u square by g, that is 3. So this is 3 kilometers. Okay, so this would be 3 kilometers. Understood, everyone?
Yes, sir.
Okay, so next question I will give it to you guys, right? Seventh one, you guys please note it down. Eighth one, you guys, okay, whenever you have noted, then we'll discuss this and then you guys will. So whenever you guys have calculated, please tell me.
Finished, sir.
Finished. Okay, Rishita and Siddhika, what about you guys?
Done, sir.
Yes, sir. Now let us do this eighth problem. So a gun fires two bullets at 60 degrees with the horizontal. So one is this one. Right, let me make a larger angle. So one is 60 degree, and then the other one is, and then with the 30 degree. So then we have this 30 degree. Right. Okay. So then the question is that let's say this is some H prime and this is H. So the question is that the ratio of maximum height for the two. So we have to find out the ratio of the 61 divided by the 31. So this is how much, guys? Please find it out and tell. And remember, H is how much? H is u square sine square theta by 2t. This is your maximum height. So please
Yes,
calculate
sir.
and yeah, please calculate and tell me what is the ratio that you are getting.
Sir, what should we take the value for G?
G you don't know. Oh, so G you know 10. So you will not need value of G. Just
So no
solve
need
this.
to use value of G.
Yeah, so you will not need the value of G.
Okay, sir.
So what are you guys doing? Yes. What did you guys get?
Calculating, sir.
Sir, I think it's A 2:1.
2:1. Okay, so Rishita got 2:1. Remember, this is sine 60 and sine of 30. Yes, Siddhika and Akib.
Doing, sir.
Not getting. Siddhika, what about you? So Akib, not Siddhika. We just have to put the values, right? So h is u square sine square of 60 by 2g. H prime is u square sine square of 30 by 2g. And if we divide these two, so h by h prime, u square sine square 60 by 2g divided by u square sine square 30 divided by 2g. So 2g cancel, u square cancel. 3:1. Okay, good. So Siddhika is getting 3:1. Yeah. So then sine square 60 is what is sine 60? What is sine
Root 3
60?
by 2.
Root 3 by 2. So then why didn't you get the answer? This is root 3 by 2 square. Sine 30 is 1 by 2. So this would be root 3 by 4 divided by 1 4. So this is 3 by 4. And 1 by 4. So 4 cancel and you get 3 by 1, which is 3 is 2. Yes, understood everyone. Good, good, Siddhika and good Rishita. So understood everyone. What was the mistake, Rishita? Yes,
I did the calculation wrong, sir.
yeah. So you will calculate. Akib, but where did you get stuck?
Sir, I was taking you as 0. So everything
Dude,
was coming 0.
no, so yeah, so that would be obvious if you take. So if you are providing a projectile with zero velocity, then will it reach something? It will be in there only, right? It will not move. Yeah,
Yes, sir.
That is why I told you guys that you will not need this value of U and G because these will cancel out. So that is why. Please quickly note it down, Akib, and then we'll do the next question.
Finish, sir.
Finish already. Good. So okay, then yeah. So from the top of horizontally, this is not an angular projection. So this question is not from the angular projection. This is from the angular projection, right? And yeah, good. So let us do this one. A shell fired from the ground is just able to cross in a horizontal direction to the top of a wall 90-meter away, right? So this is the shell, and this is the wall 90-meter away, and it crossed this shell and reached it. So this crossed the shell and reached here, right? So my drawing is bad, but this is 45 meters, and this is 90, so this would be also 90, right, guys?
Yes, sir.
Okay, now we have to find out that a shell is able to cross the direction of projection of the shell will be. So we have to find this theta, right? And what are the things which are given? We are given H, which is 45, R, which is 180. These are the things which is right. So how can we calculate? So let us write R, right? And this is U square sine of 2 theta by G. H is U square sine square theta divided by 2G. So now let us write this as U square sine of theta 2 sine theta cos theta, because that is the value of G, right? Let's say this is 1 and then let's say this is 2. So let's divide H second by 1. So H by R, right? H by R would be R is okay. H is U square sine square theta by 2G, and this is U square 2 sine theta and cos theta and by G, right? So G cancel, U square cancel, sine theta cancel. So you have sine theta by 4 cos theta, right? So sine theta by cos theta is how much? Tan theta. So H by R is tan theta by 4. So we can write as H equals to tan theta R tan theta by 4. So this is the relation between the height and the range. Understood, everyone?
Yes, sir.
Okay, so we know height, that is 45, and we know this, right? We know this R. Okay, so R is 180, and then by 4 and tan theta. So this goes in here. Tan theta is 45 into 4 divided by 180. So this is 45 to the 90 to the 180. So 180 by 180. So theta would be how much? Tan theta is 1. So for what value of tan theta, this angle is what?
45.
45. So theta is 45. Right. So this would be the answer. Okay. Understood, everyone? Any doubt?
No, sir.
Okay, so this is a very important relation that H equals to R tan theta by 4. So this relates or is this height, this range, and this angle. So please remember this also. And if please note it down, and if you have any question, please ask me that. And whenever you guys want me to scroll down the screen, you guys
So can you scroll down? yes, whenever you guys have noted it down, please
Finish, sir.
finish. Yes, Rishita, what about you?
Done, sir.
So this is the extension of the previous question. And this in this question, they are saying that we have to find the initial velocity, right? U we have to find. So we know that H is 45, right? Theta is 45 degree. So we have to find out what is U. So you guys please find out using these relation. Please find out what would be U.
Okay, sir.
Yes, guys, what did you get?
Sir, doing calculation.
Sir, I'm getting none of these.
None of these. Okay, so
Sir, I'm getting 30 root 2
30.
meter per second.
So you guys have a disagreement, right? 32. So Siddhika also got. Yes, so where was the mistake, Rishida? There is some calculation mistake, right? H is u square sine square theta by 2g. H you already know. Into 2 into g, that is 10. And then u we have to calculate sine square of theta, which is 45. So sine 45 is 1 by root 2, right? So this would be 1 by 2. So this 2 goes in here. So this is 180 into 10 and then u square. So this is 900 into 2 and u square. So u is root of 900 into 2, which is 30. Yes, where was the calculation mistake? Did you find, Rishita?
Yes, sir.
So everyone, very good. So now let us do the. Okay, you guys already solved this one, so no need to note it down. So then let us do this 24th one. Right. So a body of mass m is thrown upward at an angle theta with the horizontal with velocity v. So we have projected this. So we have projected this projectile with velocity v, right, with an angle theta. So while raising up the velocity of the mass after t second, let's say this is after t second, the object reaches there after t second, right? So this is the velocity at this point. Okay. Now we have to find out that Hiba Aziz, who is Hiba Aziz? Yeah, so while rising up at the velocity of the mass after t seconds will be. So we have to find the velocity, magnitude of velocity at this point, right? So what are the things that we have to calculate at this point after t time? We got disconnected. Okay. So at this point, what are the things that we need to have? This is vector v. So what are the things that we
Velocity?
need? So we need two components, right? Vx and Vy at this point.
Yes, sir.
So we need Vx and Vy. Correct, everyone?
Yes, sir.
Now, as Rishita has told us, this Vx, so this is my initial velocity. So initial velocity has two components, right? Ux is v cos theta and uy is v sin theta, right? So as Rishita has told us that this x component will always be the same. So Vx would be v cos theta, Clear, everyone?
Yes, sir.
Now, what would be Vy? So you guys tell me what would be Vy. Let me know if you guys remember the projectile one or not.
Sir, V sin theta?
V sine theta.
Yeah, because we're telling Vy, it will be up. So sin theta.
So it will be same as this one, Uy.
Yes, sir.
At this point, we have reached here. So velocity is increasing or decreasing? Velocity is decreasing, right? So
Yes, sir.
at this point, what would be the? So you are saying that it will have the same velocity as this one. Do we have any acceleration in the y direction?
No.
No, sir.
We don't have any acceleration in y direction.
So it will be downwards.
Yeah, so that
Acceleration.
is y direction, right? This up down or y direction.
So it is opposite to Y, right?
Yeah, so that is minus j, but in the y direction, right?
Yes, sir.
Y component, right? So yeah, so x component is 0, but ay, as you have said, that is, yeah, opposite. So, but that is the y component, right? So that is minus g, right, guys?
Yes, sir.
Okay, so what would be Vy? This is the first thing that we discussed in the uh, projectile class. Okay, so let me write the conditions. Uy is v sine theta, ay is minus g, time is t. So Vy would be Uy plus Ay t. So Uy, which is V sine theta, Ay is minus G. So this. So this would be Vy, right? The velocity would be reduced by this factor. Y component will reduce. That is why at this maximum point, your velocity y is 0.
Yes, sir.
So then this Vy would be V sine theta minus gt. So now we have Vx, we have Vy. Then we can calculate the magnitude of V, right? So what would be the magnitude of V? This would be root of Vx square plus Vy square. So Vx is V cos theta whole square and Vy is V sine theta minus gt whole square. So this root n. So this would be V square cos square theta and V square sine square theta plus g square t square minus 2V sine theta gt. Correct?
Yes, sir.
Can we simplify this further?
Yes.
Yeah. So how can we simplify that?
By taking V common.
V common. Okay. So let's take these two terms, right? So in these two terms, V square is common.
Yes, sir.
So V square and then sine square theta plus cos square theta and then g square t square minus 2 sine theta gt. So what is
Sir,
this
here also
value?
we can take common
V.
GT.
GT, how? So in here, yeah, in here we can take, but that is not necessary, right? Because this will not simplify things. This will simplify things, right? So what is sine square theta plus cos square theta, guys?
1.
1, right? So this would be b square plus g square t square minus of 2 b sine theta g. Of course, we can take GT common in here, but in our answer, GE terms are separated, right? So we have got this term, we have got this term, so no need to take in common, right? So what would
Yes,
be
sir.
the answer? This would be the answer. Any doubt in this question, guys?
No, sir.
Yeah, so please note down this part. Yeah, whenever you guys want me to scroll down the screen, please no. So
Finish, sir.
done. Good.
Done, sir.
Done. Okay, what about you?
Yes, sir.
Now let us do the next question. Okay, so we will skip this question now. This one and okay, we had another question. This is quite important and just quickly do this one and then we'll move on to the next. Then the time of flight of stone will be. Okay. So a stone is thrown at an angle theta to the horizontal reaches a maximum height h, then the time of flight of stone would be. So remember this answer is in the form of h and g or sine theta also, right? So
Yes, sir.
this question you guys try at your right because you know t which is 2u sine theta by g, you know h which is u square sine square theta by 2g. So you have to write t in the form of h. This is what you have to do, right? So understood the question, guys?
Yes, sir.
Yeah. So please try this question at your home. And then this question. Yeah. So please take the screenshot of this question. Okay, this question. Take the screenshot.
Yes, sir.
Everyone taken?
Yes, sir.
Yes, sir.
Yeah, please try this question at home. So now the speed of a projectile at its maximum height is root 3 by 2 times its initial speed, right? So we have, so this is the projectile and initially it has the speed u and the speed of projectile at its maximum height. So at maximum height, what is the magnitude of the velocity at maximum height? This we did just a moment ago.
The u sine theta will be 0.
Yeah, so u sine theta would be 0. So the v is u cos theta I, right?
Yes, sir.
So magnitude is u cos theta, right? So magnitude, let me write as v magnitude. V is u cos theta, right? In here, the magnitude is this vector is u, which is u cos theta I hat plus u sine theta j hat, and its magnitude is u, right? In here, this is the vector, and its magnitude is v, which is u cos theta. So now, what is the question telling? That speed of the projectile at its maximum height. So v, this is root 3 by 2 times initial speed. So this is given, right, everyone?
Yes, sir.
So v is u cos theta, and this is equal to root 3 by 2u. So u cancel, cos theta is root 3 by 2. So what is theta?
30.
30, right? Good. So 30. Now we have calculated theta. So now if the range of the projectile is n times the maximum height attained by it, right? So range of projectile is n times maximum height attained by it. Then n is equal to. So we already got the relation between r and h. And what was that? So h was r tan theta by 4. Am I correct?
Yes, sir.
So let us put this value in here. So r is n, h is r tan theta by 4. So r cancel, and what is the value of, so this is 4 and y tan theta equal to n. So what is the value of theta that we got?
30.
So tan of 30 equals to n. So n would be 4. And what is the value of tan 30?
1 by root 3.
1 by root 3. So this goes in here. So 4 root 3. So this is the value of n. Any questions, guys? Any question?
No, sir.
No,
Okay,
sir.
so please note down from
Finished, sir.
finished. Okay, then please note down this part. Yes, whenever you guys have noted it down, please
Yes, sir. Finish.
finish. Ishita and Siddhika, what about you guys?
Done, sir.
Good. So now, okay, so now let us do the next question. Okay, so a particle is projected from the ground with an initial speed of v. Right, so initial speed is given. So this is theta and this is v. This is theta, this is v. So u is v cos theta, right? I hat plus v sin theta j hat. So this is the velocity. Okay. Now what do we have? With the average velocity of the particle between its point of projection and highest point of the trajectory, right? So this is the point of projection and this is the highest point of the trajectory, right? So we already know that to reach here it takes t by 2 time. From here to here it takes, yeah, so we have this one, right? And this is h, and from here to here this is r by 2, and it takes t by 2 time, right, to reach here. So particle starts from here and reaches here at t by 2 time, and it takes the same time to reach here, right? So that is why total time of flight is t, and then this is half time. Now we have to find out average velocity. So what is the average velocity? What is average speed, guys? What is average speed?
Sir, like dx by dt, like that.
No, that is instantaneous one. We don't know the how the so parameterization of
Delta x by delta t.
delta x by delta t when we know the initial and final velocity, right? So then we calculate delta x by delta t, right? But we don't know the initial and final velocity. That would be hectic to calculate. But we do one thing. The uh, the first formula for average velocity. So what was the average
Uh,
speed?
Total displacement by total time.
Yes, yes. So
Oh,
total displacement by total time. Is this okay, everyone?
yes, sir.
So total displacement from here to here would be what? This, right?
Yes, sir.
So this is my total displacement. This is h, and this distance is r by 2. So what would be this displacement? Let's say AB. What would be AB?
R by 2.
AB. This is H, this is R by 2. So what would be AB?
H square plus r by 2 whole square root of.
So this is AB, right? This is the hypotenuse, right? This is perpendicular, this is base. So this is AB is hypotenuse. Understood, guys?
Yes, sir.
Okay, and time we know. Time from here to here, from reaching to here, this is t by 2. So that is why total time is t by 2. So now let us calculate all the values. What it will. Okay, so h, we know that h is r tan theta by 4, right? And then this is square plus r square by 4, right? Is this correct, everyone?
Yes, sir.
And then this is what? So then this is t by 2 is 2u sine theta by g. So now this r is common, and this 2 is also common, right? So we can, let me write it first, simplify this. So this is r square tan square theta by 16 plus r square by 4, and then this is 2u sine theta by g, right? Then this would be how much? 60. So r square by 4 is common, so r by 2 taken outside, and then this is tan square theta by 4 plus 1 divided by 2u sine theta by g. So this is r is u square sine of 2 theta by g, right? And then this is 2u sine theta by, this is what? So by g. And this is root of tan square theta by 4 plus 1. So then this would be how much? So this u square u cancel, g cancel, and sine 2 theta is 2 sine theta cos theta divided by 2 sine theta, right? So this sine theta also cancels. This 2 also cancels, and this u also here. And this is sine square theta by 4 cos square theta plus 1. So then this would be how much? This is u cos theta, right? And then this is sine square theta plus 4 cos square theta, and divided by cos 4 theta. So we can take out 4 cos square theta outside. So this is u cos theta by 2 cos theta. So this cancels. And I can write this as 1 minus cos square theta plus 4 cos square theta. So this is u by 2 and 1 plus 3 cos square theta. So this is the average velocity. Is this clear, everyone?
Yes, sir.
Okay, there was this lengthy calculation, but yeah, so we can. This is the idea. So please note it down, and then we'll do the next question. This is point of projection. This is point of maximum trajectory. A is a point of projection. B is the point of maximum height or trajectory. Okay, so in the next class, I will start this relative motion in 2D. So in that, I will do this rain man problem, rain umbrella, wind, river, and river crossing problems. All these problems. Whenever you guys want me to scroll down, please tell.
Finished, sir.
Finished. Yes, whenever you guys have noted it down, please tell.
So can you scroll down? Sir, I'm done.
Good.
Finished, sir.
Okay, Siddhika, what about you? Yes. Oh, Siddhika got. Yeah, Siddhika got this. Oh, so we will stop it here and see you guys after 1 hour, right?
Yes, sir. Thank you, sir.
Bye, bye everyone. Bye.
Thank you, sir. Bye, sir.
Assalamualaikum.
Welcome, Sham. Bye, guys.